In this video we have a definite integral from 3 to 5 of x multiplied by the square root of x squared minus 9. Notice the derivative of x squared minus 9 is 2x. And we got an x here as a factor. So that tells me that a u substitution would work. Let u equal to x squared minus 9. Then du would equal to the derivative of x squared minus 9 would be 2x. Then I'd have the dx. So to transform this integral into one involving u, x squared minus 9, this would be my u right here. And then putting the x and the dx together, divide here by 2, x dx can be replaced by du over 2. I get the same thing if I would solve this for dx and replace the dx by what I got, same thing. So then this is going to equal, it'll be the integral, okay, this will be u here, that'll be to the 1/2, and then the x dx would be du, that's over 2, I just put the 1/2 out in front. Now I'm going to change the limits of integration here. I don't have to do that, but that's an option. We'll look at it both ways here. So here the variable is x, so when x equals to 3, what is u? So for the lower limit, x equal to 3 would imply, see, 3 squared is 9 minus 9. That means u is equal to 0. And then for the upper limit, x equal to 5, place the x by 5, would imply that u is equal to 16. So now these will change then from 3 to 0 here, and from 5 to 16. Then it's just a regular integration here with respect to u. So I add 1 to the 1/2, that'll give me 3/2, and then I divide the 1/2 by the 3/2 and invert and multiply, so this will give me the 1/3. I just split it over 3, and then this is integrated then from 0 to 16. So we evaluate. Put a 16 right there, so it'll be 16 to the 3/2 power over 3, and then we subtract the value at 0. So it'll be 0 to the 3/2. Of course, that's going to be 0. I'll just go ahead and put it on there anyway. Then over 3. So this goes to 0 there. So this is just giving me 16 to the 3/2. Several ways I could evaluate this. Again, this is 3/2. And several ways you can evaluate that. Let me just give you a little formula here. X to the m over n. We're assuming here m and n are positive integers. Several ways you can write this. You can write this as the nth root of x to the m. That's also the same thing as the nth root of x to the n power. So for this one here then, to evaluate this 16 to the 3/2 power, I could say 16 to the 3rd power, compute that out, and then take the square root. Or I could take the square root of 16 and then cube it. Well, that's easier. Square root of 16 is 4, and then 4 to the 3rd power is 64. And that's over 3. And that's what you have. You could also just evaluate this any way you want. You can still use the u substitution here and not change the limits of integration. You can leave the limits of integration the same. So what I'm saying is, using the u substitution, you get it down to here, and then go back to the original variable and say, okay, this is u is x squared minus 9 to the 3/2 power, and that was over 3. So as long as you go back to the original variable, then you can use the original limits of integration and evaluate this from 3 to 5. So notice 5 squared, 25 minus 9 is 16. So you get 16 to the 3 has power again, over 3. And of course that's 64 over 3. And then it's minus the value at the lower limit. Well, 3 squared is 9. 9 minus 9 is 0. 0 to the 3 has power is 0. So that just comes out to 0. So we still get the same thing. Thanks for watching. We'll see you next time.